Imagine a 52-meter wide aircraft flying directly over enemy territory, and radar sees almost nothing. This is the B-2 Spirit, one of the most advanced stealth bombers ever built. With a wingspan nearly as wide as a football field. The B-2 is massive, yet on radar, it can appear as small as a bird. Built at a cost of roughly $2 billion per aircraft, it remains one of the most expensive airplanes ever produced. But how does something this big become nearly invisible? To understand that, we need to go back to the Cold War. The incident that changed everything on May 1, 1960, a Lockheed U-2 spy plane took off from Peshawar Air Base in Pakistan on a secret CIA mission over the Soviet Union. The United States believed the U-2, flying at around 80,000 feet, was untouchable. At that altitude, American officials assumed Soviet missiles couldn't reach it. They were wrong. Soviet radar detected the aircraft. After several attempts, an S-75 Divina missile struck the plane near Sverdlovsk. The pilot survived and was captured. The Soviet Union publicly revealed the pilot and the wreckage, causing global embarrassment for the United States. That moment changed military strategy forever. The Soviets began strengthening their air defense systems, eventually developing advanced missile networks like the S-300. Meanwhile, the U.S. realized that traditional bombers such as the B-52 Stratofortress would struggle to survive inside heavily defended airspace, so America made a decision. Instead of flying higher, they would become invisible. Birth of the stealth bomber in 1978, the U.S. launched the Advanced Technology Bomber Program. The goal was simple but revolutionary: create an aircraft that could enter hostile territory, deliver its payload, and leave without being detected. The result was the B-2 Spirit, which first flew in 1989 and officially entered service in 1997. Its most defining feature is its flying wing design. Unlike conventional aircraft, the B-2 has no vertical tail or sharp angles that strongly reflect radar waves. Traditional tails act like mirrors for radar signals, bouncing them directly back to detection systems. The B-2 eliminates that weakness. Its smooth, curved surfaces are carefully shaped, so radar waves are deflected away instead of returning to the source. When radar signals don't bounce back, the system struggles to confirm a target, but shape alone isn't enough. The B-2 also uses radar-absorbing material special coatings that reduce the amount of radar energy reflected. Combined with its design, the aircraft's radar cross section is extremely small, often compared to that of a small bird. In simple terms, it's not truly invisible, but it's extremely difficult to detect and track reliably. Beating heat, seeking missiles, modern air defense systems don't rely only on radar. Many use infrared sensors that detect heat from jet engines. So the B-2 was engineered to reduce its heat signature as well. Its engines are buried deep within the wing structure. Instead of releasing extremely hot exhaust directly into the air, the gases are mixed with cooler air before exiting. This lowers the temperature of the exhaust plume, making it harder for infrared guided missiles to lock on. The aircraft typically operates at altitudes around 50,000 feet. At that height, thinner air reduces drag and improves fuel efficiency. With a range of approximately 11,000 kilometers without refueling, and the ability to refuel mid-air, the B-2 can reach virtually any target on the planet. Electronic warfare advantage stealth isn't just about avoiding detection, it's also about confusing the enemy. The B-2 is equipped with advanced electronic countermeasures, or ECM systems. These systems analyze enemy radar frequencies and can send back deceptive signals. In some cases, radar operators may see multiple false targets. In others, the aircraft's position may appear shifted from its real location. This electronic deception makes tracking even more difficult. Firepower and missions. Despite its stealth, the B-2 is a heavy strategic bomber. IT can carry approximately 18,000 kilograms of payload, including precision, guided munitions, and nuclear weapons. All weapons are stored internally to maintain its stealth profile, no external bombs or missiles that would increase radar visibility. Since entering service, the B-2 has participated in major operations, including Operation Allied Force Operation, Iraqi Freedom Operation, Odyssey Dawn. One of its most remarkable missions occurred during the Afghanistan conflict. B-2 bombers flew a 45 HAR round-trip mission from the United States, conducted strikes, refueled mid-air, and returned without landing. Few aircraft in history have demonstrated that level of global reach. The cost of stealth, only 21 B-2 bombers were ever built. Each aircraft costs around $2 billion, making it one of the most expensive military aircraft ever produced. And the expense doesn't stop there. Maintaining stealth is incredibly demanding. After each flight, the aircraft undergoes detailed inspections to ensure its radar-absorbing surfaces remain intact. Even small surface imperfections can affect performance. Stealth is not just about advanced engineering, it's about constant precision maintenance. Final thoughts, the B-2 Spirit was born out of Cold War rivalry and technological competition. It represents decades of research in aerodynamics, material science, and electronic warfare. It may not be truly invisible, but in modern warfare, being difficult to detect can be just as powerful. And that is what makes the B-2 Spirit one of the most remarkable aircraft ever built. Thanks for watching. See you in next amazing weekly episode.